Welcome everybody to today's AI seminar. So we've been running these seminar series since last year, and today it's my great pleasure to host a guest from Melbourne. I would like to start with the Acknowledgement of Country. The University of Queensland acknowledges the traditional owners and their custodianship of the lands on which we meet. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognize their valuable contributions to Australian and global society. So welcome again, everybody. Just a word about the AI seminar series. As I mentioned, we've been running it for about a year or so. Every month we have one or two seminars. A lot of our industry partners, our partners from government across UQ, internationally as well, and nationally, like today. And it's really about connecting to AI research, both locally and globally. So today, again, my great pleasure to introduce our speaker, Tim Miller. Tim is joining us from University of Melbourne, where he is heading the Centre for AI and Digital Ethics. Tim is not a stranger to UQ. He's a bit of a homecoming, so did his PhD from UQ in software engineering. And as we were just walking through campus, I could see lots of hand waves, and even in this room, so familiar faces. That's really lovely and wonderful to see. Tim's particular interests are in human-centered AI and explainable AI, very hot topics and very important topics. And there's huge interest over there on these topics, which I can see. We have got 44 people joining online and people in the room here as well. So we were just making sure that all the technology is synced up. Hopefully it is, once we've got the download done. Shall we have a look, Tim? So this one. Yep. Okay. Works now. Yeah, I've got a confirmation from colleagues that the online is working as well. Okay. Okay, good.
And they can see the screen?
Yes, I think they can see the screen. Over to you, Tim.
Thank you for the invite. And thanks. Hopefully everyone can hear me here. So I'm going to start off explaining where the title of the talk came from. And so this is a practice run. I'm giving a keynote talk at ICHCAI at the end of July. And I'm going to talk a little bit about explainability. And it's all right.
Just make sure that you're actually sharing.
And I'll just keep going for a minute. And so I'm going to talk about basically some work I've been doing over the last 5 years in this space, maybe 10 years, you could extend it to 10 years. Some of the problems that we've been experiencing doing some of these things that in really making progress, and how hard a problem it can be to do really good decision support using artificial intelligence. That in our lab we've discovered, and other people in other labs have discovered, and some people have written off explainability as a useful technique in a lot of decision making. And I'm going to sort of look at why I think it hasn't worked that well, and what I'm sort of planning to do in the next 3 to 5 years in our lab to address some of the issues around explainability. So in around about, I've been doing stuff in trusted autonomy and trusted systems for about 10 years. And around about 5 years ago, a lot of people started getting interest in explainability, and especially in machine learning, in the area of machine learning. And we were looking at a lot of the research that was coming out, and we were really asking, when we talk about explainability, we really wanted to know, my slide's going again, explainable to whom? When we're talking about explainability, who was the intended audience that we were interested in? And the observation we made at the time was actually what a lot of let's say AI practitioners and researchers were doing was we're coming up with explainability techniques that were for themselves, that's useful for themselves to explain, so they could understand models, and then making a big leap in assumption that's saying, well, this will be useful for everybody else as well. And so this lovely graphic that we've got here, really what it meant was a lot of, let's say lay people were down embedded in the nuts and bolts of how a particular decision-making mechanism would go, but we were arguing that's probably not the best solution. And further to that, a lot of the evaluation, people were saying, well, here's some explainability technique that we've got. Here's a couple of examples of it. That helps us to understand what's going on. Therefore, this must be explainable. And we sort of questioned whether that was a really good way to do evaluation. If you're one of the world leading experts in some particular decision-making, then you're really the worst person in the world to decide whether this is useful for somebody else, right? And so we had there's sort of a drive in the community, our lab and some other people at different labs to make, let's say, explainability more human-centered. And so we kind of look at it like this. There's the scope of XAI. It starts with, obviously, artificial intelligence is one group. I say HCI is another group that's very important for us, but also in the middle, cognitive and social science. We're talking about cognitive psychology, social psychology, and philosophy mostly are the three scopes. And then the fourth one is, of course, the domain you're working in, whatever that's going to be here. But from a research perspective, we say that this is probably the scope, is these three things. And if you put these three things together, you get this field called human-AI interaction. And around about 5 years ago, we felt that not many people in that human-AI interaction community were really interested in this topic of explainability. And yet, really, to us, this is where explainability sits in. It's just a sub thing of that. It's an interaction between people and machines in order to understand how and where models work and how decisions are made. And it was kind of surprising that we saw that pretty much all of the research was coming out of AI. I think since then, this has changed a lot. We've got a lot more of this research being drilled back towards the center part. If you go to CHI, there was 2 workshops on HCI at CHI this year, which is the sort of big HCI conference. There was panels at CogSci in 2019 and 2020 on this, and people are really getting involved in this scope. But really what I was pushing 5 years ago was we need to take cognitive and social science more seriously. And so let me give an example of why. And I guess the people sitting at home can have a vote on this as well if you want. So let's assume we have a GP and they have a patient that's coming to visit them. And the patient said, I just want to come and see you because I've got a few issues I want to discuss. So there's 3 things that have happened. I've recently put on a bit of weight and I'm not sure why. I've been suffering from fatigue and nausea. And before the patient come in, the doctor's thinking about, well, what could possibly be the cause of this? So the doctor goes back over the history and says, well, I realized recently that the patient broke their ankle or something and they might have stopped exercising. That could explain why they put on a bit more weight than what they expected. And there's about 80% chance, I think, that's the cause of their weight gain. There's been mononucleus going around the community. That could explain their fatigue. And I'm about 50% sure that's it. And I noticed, her kids were in last week and they had a stomach virus. That would explain her nausea. And I think there's about 50% chance they had that. But also I know that she was trying to get pregnant last time I spoke to her. That would explain the weight gain and the fatigue and the nausea. But I think there's about a 15% chance that she's become pregnant in the last month or whatever. So the question I want to ask you, and I'm going to get you to put your hand up, and online you can vote for this as well, is, well, what's the best explanation for these 3 symptoms of weight gain, fatigue, and nausea? Is it that this person has stopped exercising, they have mono and they had a stomach virus, or are they pregnant? So who thinks, maybe on the chat, if I can bring the chat, I don't know if you can see the chat if I bring it up at home. We can see it here. Who thinks it's the first one? They stopped exercising, they have mono and a stomach virus. Put your hand up in the audience. You have to vote, by the way. Who thinks it's the first one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of about 25 maybe. Who thinks it's the second one? Pregnancy. 1, 2, 3, 4, 5, 6. Okay, roughly a little bit. We got one here. Okay, so why would it be the first one? The three things. Why would you say that if you said that? Anyone? More likely events, yeah. You multiply, well, I've got them covered up now. You multiply 80 by 50 by 50, you get 20, right? If you assume they're independent events, that's more likely. Okay, so why did you say the second one if you said the second one? Anyone? combines everything together. Yeah, it's exactly precisely right. So let me see what people at home said. 1 explains most symptoms. So what's the answer? The answer is there is no answer, because I didn't actually quantify what I meant by best. So if you want the most likely, then the first thing that's more likely. But actually this actually comes from a study from Amy Marcus Newell and one of her PhD students or something, she's a cognitive scientist, that showed that overwhelmingly people will choose the second one in this study, even though it's less likely. And in fact, you basically have to make the probabilities of those first three double the other one before people will start choosing this as the reason that they think is the best explanation. Why? Well, their hypothesis comes down to the fact that what people prefer is they would prefer one explanation to explain multiple causes rather than multiple explanations to perform multiple causes. This research kind of indicates that we have a cognitive bias to say we prefer simpler explanations rather than more complex explanations. And you can see other studies around this. Philosophers have proposed this and people have studied things around. It's not that simple though. Studies that came out after this, and in fact, we've got one under review now, looking at this in a project we've got with a DST group. It's not that simple, actually, that, simple is better. Actually, it turns out it's a bit of a trade-off. It depends on how complex the phenomenon you're explaining is. So if the phenomenon is a bit more complex, such as explaining a causal chain of reasoning by an artificial agent, people actually prefer a little bit of complexity. They want to understand how all the causal events link, but not an overwhelming amount of complexity. Why this example? Well, because I think if we're doing explainability, this is probably interesting for us to know. And I'm not saying if we're doing explainability, we should choose the simplest one all the time. I'm just saying that the people that you're explaining to are going to prefer this bottom one, even though that top one might feel like mathematically the one that we should be granting. And probably we should know about these types of studies before we indulge in explainability. But I'm not naive enough to think that we can all go and read all this literature from cognitive science and philosophy and social science. So when I was on sabbatical in 2018, or 2017, maybe 2017, I touched down and thought, oh, I've got 6 months. I'm going to spend the first 4 weeks really reading the literature from philosophy, cognitive science, and social psychology, and I'll get on top of it. And it took me 4 months to get through all of the literature that I found. I did a fairly comprehensive survey, around about 250 papers that I looked at. I read 200 of them and fed quite a bit of detail. And then I summarized probably 150 most related ones in this article. It's published in Artificial Intelligence that really looks at how do people explain complex phenomena to each other. And my hypothesis here is that if we look at how people explain complex phenomena to each other, maybe that's going to be a good start for how machines should explain complex phenomena to people as well. It's been quite impactful, this research. In fact, I gave an invited talk at ICAPS on Friday, and Sylvie Thebu was introducing me, and this turns out this is the most highly cited paper in AI for the last 5 years in the journal AI, which I didn't know until then. So it's been quite impactful, and it's why I get invited to give keynote talks now, I think, is this work. So I'm going to talk about in this talk the 3 main lessons I learned from reading all this stuff, how we've applied some of it and how other people have applied it, and why I think it doesn't quite go far enough. So what are the key lessons that I learned in reading this work? The first one is that explanations between two people or between groups of people are contrastive. So this is a quote from Dennis Hilton, who was a social psychologist at the University of Toulouse, who I was lucky enough to work with a little bit when I was there on sabbatical. And he says that the key insight is to recognize we don't explain events per se, but we explain why one event occurs rather than some other event that we expected. So to break this down, what it really means is we usually only want something to be explained when we don't understand what happened. So it's puzzling. And usually that means we expected something else to happen. When that something else doesn't happen, we ask, why did A happen rather than B? And most people in philosophy and social psychology and cognitive psychology agree that all explainability, all explanations is like this. We always expect something else, or we always have a model that we're building against. Why does this matter for artificial intelligence? Well, let's go through a toy example that I had in a paper in knowledge engineering review. Let's say we've got some classifier that can classify images of arthropods, spider, beetle, bee, fly, and it does it by recognizing these 6 properties across the top here: legs, whether there's a stinger, how many eyes, whether it has compound eyes, which just means its eyes are built up from multiple eyes, and how many wings. And so if you asked it, why did you classify that as a fly? Well, it would presumably hopefully tell you, well, I recognize this image has 6 legs, a stinger, 5 eyes, compound eyes, and 2 wings. And that's pretty, I think that's pretty convincing. But if you asked, why is it a fly rather than a beetle? Why did you classify a fly rather than a beetle? Well, it could basically say, well, because a fly has, these properties here, and a beetle has these properties here, and that would be a good explanation for, that might be an explanation for why. But it wouldn't be a very good explanation. A really good explanation would be just to highlight these 2 things. I thought it was a fly rather than a beetle because I recognized it had 5 eyes, and beetles only have 2 eyes. Therefore, that's what a fly would be. And all the other things, like the number of legs, the stinger, the compound eyes, and the wings, they're the same between those 2 things. And so from an explanatorially relevance perspective, from an explanatorial perspective, all those other things are irrelevant. All that matters is the thing that's in the title, the thing called the difference condition, which was proposed by a philosopher called Peter Lipton. And he says, what we do is we should focus on what's different between these 2 classes, because that actually tells us 2 things. The question itself gives us a window into the mental model of the person. What don't they understand? Presumably they probably already understand it's got 6 legs and a stinger and compound eyes and wings. That's why they're mistaking it from a beetle for a fly. But it also allows us to narrow down the amount of information we're presenting to someone. Remember the exercise we just did. Smaller is sometimes more convincing. And so this is maybe not a very convincing example. It's a toy example, but if you consider most contemporary machine learning models, even tabular data would have, hundreds of features, maybe thousands of features. We did a bit of work with FICO. Their credit scoring model has over 10,000 features. If you can narrow down from 1,000 features down to 10 using this, well, that's pretty powerful. It's a pretty powerful mechanism. And in fact, in the last, sort of 4 or 5 years, we've seen a lot of people working on this in various subdisciplines of artificial intelligence to give these explanations. So that's lesson number 1. Now I'll talk a bit about our experience doing this later. The second one is that explanations are social. So they're an interaction between people. And so I've got another quote from Dennis Hilton. I did read authors other than Dennis Hilton, but he just tends to come up with very quotable stuff in his papers. Causal explanation is a form of social interaction. And, the verb to explain is 3 place. Someone explains something to someone else. And he showed that causal explanation adheres to the rules of conversation. So you might be familiar with Grice's maxims. He showed that it adheres to those things. And so I want to be careful. I'm saying that explanations are social. It's between 2 things and there's an interaction. It doesn't mean that I think explanation should be verbal, should be textual or verbal. It just means that what happens is when you ask for something, some clarifying information, explanation is more than a statement. It's more than a statement that comes back. And it's really unusual for someone to ask why something happened and get back an answer and be completely satisfied. There's quite often a follow-up and things work around. So we did a bit of work in our lab. So this is from a paper from my student Prashan, who's just graduated a few months ago, where he went and took what's called a naturalistic decision-making approach to explainability. And don't worry too much about the detail on the slide. I'll talk you through it in a minute. He went and looked at 400 different explanatory dialogues from a range of different sources, court transcripts, Reddit Q&As, online interviews, these types of things, and looked at how people explain complex phenomenon and came up with this, like a state machine model of explanation between people. And I don't want to go through all the details, but what you can see is the default kind of idea. Hopefully you can see my pointer at home. The idea we really have is that someone asks why something happened and we tell them, and that's the end. But actually between 2 people, it doesn't happen like that. Often there's return questions and there's some follow-up. But even more importantly, quite often we get into an argument about why. So someone says, why did this happen? Oh, well, because, this was the state of the world at this point. well, actually, I don't agree with you that this was the state of the world, or I don't agree that's a cause of that. Can you clarify? And they might resolve that argument and then come back to the explanation, or they might fail to agree and stick out. What's important here, though, is that there's interaction between people, and it seems that from explaining from a machine perspective, we're going to have the same problem. And like I said, I don't think this means we're going to have a conversation, but surely if you have visualizations, what you want to do is allow people to explore deeper into a visualization, which is like asking a return question. And you want people to be able to question the information that's going on and question its veracity and correct it if it's wrong. And so we validated this in some what we call Wizard of Oz studies, and showed that, yeah, if you play the part of the artificial agent and you follow this protocol, the people doing it also follow a similar protocol most of the time. And it's very rarely just simple question answer. And the third lesson, that's lesson 2. The third lesson is that what I say is explanations are selected. So most complex events have a multitude of causes in the sort of tens and thousands. But when people ask, oh, that was interesting, why did that happen? Other people are quite adept at giving 1 or 2 reasons, and that seems to satisfy everybody, despite the fact there's maybe 1,000 other reasons why something happened. And Daniel Kahneman and Tversky, who you might know from their famous textbook, have showed similar things. I'm not going to read this thing here, but they show in these big clips of text like this, if you ask someone, well, why did this complex event happen? People will just highlight one thing. This was the reason why. But more importantly, there are patterns to the way, there are almost like biases to the way that we seem to understand how explanations are selected. So in my reading, I kind of found some that I thought were really important. And so if we imagine this line across the top is time, and there's a complex chain of events that happen in order to cause an event, and we ask, how did that event come about? There seems to be this is the model, I think, based on my reading, the way it works. So people tend to prefer something that's happened more recently over something that's further in the past, which makes sense, right? Something more recent seems to be a more likely cause. So we call that temporality. That makes sense. But then if something abnormal happens, something that's unusual and doesn't usually happen in this environment, people will trace through something that's more recent to something that's older, and they'll grapple onto that. And that kind of makes sense, right? If something happens all the time, we don't need to tell people about it. They're probably going to understand that that's a regular cause. But if something unusual happens to cause an event, that's what people hold on to. If there's something intentional, like an intentional action that a human actor has played, they'll trace through abnormal events and more recent events and grapple onto that. So it seems like human agency has an input into this. Now, this is interesting if we're dealing with data with human actions, but it's probably also interesting if we're doing autonomous systems where we tend to ascribe intention to machines, and therefore intentional actions from machines might be also important. And perhaps not relevant, but I think quite important, I think quite interesting. If human intentional action is deemed as being immoral, that's the strongest weight of all. So they did studies that showed, so-and-so, whatever it's Mr. Jones' wife had an accident at home and she was lying on the floor for 2 hours. He didn't get home in time. And if you say things like he stopped off to get groceries, people don't attribute that as a causal event. But if you say he stopped to get cigarettes and alcohol, people tend to attribute that as a causal factor here, despite the fact he stopped off for the same amount of time. So people would trace through to this kind of immoral event here. I don't know if that's relevant, but it's interesting. So I thought it was worth adding. So the point here is you've got lots of causes and people tend to select a couple of them, and there tend to be patterns that people will use to select them that are quite general, that aren't tied to a specific domain. And indeed, there's been a bit of work in studying how people select these, but perhaps not as much as what I would expect. Okay, and I want to take one brief, that's my 3 lessons, but I want to take one thing that I also pushed in this paper was about looking at this from a human study point of view, looking at it from a human-centered point of view, and doing human-centered studies. So if we claim that we've got some explainable technique, trying to scientifically demonstrate, this helps people understand and make decisions. And this is a sort of warning of what happens when you don't. Not my study. This comes from a talk from Bean Kim, who's at Google Brain, one of the Google things, who does a lot of interpretability work. And they saw this example. This is from her talk that said, this was on the left is an image that has been given the label automated teller machine by a classifier, and using a technique called saliency maps, which highlight the important pixels in an image, they generated the explanation on the right. And when they were playing around with these saliency maps, they looked at this explanation and said, well, that's kind of weird because the most important pixels were these. This is the strongest predictor here with these pixels here, which actually is the wheels of this trolley here. Why would the wheels of a trolley be such a strong predictor for ATM? They did some computational studies, and what they showed was there was this body of work for about 2 or 3 years on saliency maps, and most of it was entirely invalid. What most saliency map generators were doing edge detection, and that's it. They were taking random convolutional neural networks with random parameters. So these were not predicting, these had no predictive power at all, and showing that the explanations you generate from a properly trained CNN model were exactly the same as the ones you generate from a randomly trained CNN model. And therefore they weren't actually revealing anything about the underlying causal mechanism at all. It was 2 or 3 years of research, of almost an entire body of research wasted. Not all of the saliency map tools did this, but a vast majority of them. Now, the lesson that I would like to take away from this is, had they done a proper human study from the very start, they would have figured it out very quickly. Because you see, what they did was use their intuition and said, that's an automated teller machine on the left. We're generating an explanation on the right. I can see that that's useful causal information. Therefore, this must be useful. But what you did was the researchers read what they wanted to read out of this. They didn't actually read anything useful. If you were doing a proper study, you might, for example, do a very simple study called a task prediction. You might say, well, here's an image to your participants. You might say, here's an image, and you give them that image. And you'd say, that's the explanation we get out of it. Could you tell me what this would be predicting, what our model would predict from this? And it seems very unlikely they would predict automated teller machine from this explanation at all. They would probably predict trolley or person or something like that. Doing these proper studies, they would have pretty much found out very soon that they're not really generating much insight into what's going on. There's a bit there, there's a bit of signal, but for the ones that are genuinely good, but there's not much. Doing proper human-centered studies allows us to see, well, do these things really help people understand? Do they help people make better decisions? Okay, so I want to talk just really briefly about a couple of projects we've applied these insights. And then I want to talk a little bit about why some of them haven't worked. So in our lab, we've been providing a whole lot of the insights that I talked about here on a range of different techniques in a range of different domains with a range of different collaborators, quite a bit with Defence Science and Tech Group and a few others in order to sort of apply these techniques. And we've had quite a bit of success, but some places we've really struggled to make meaningful impact. And I'll talk about why I think. Whoop. And so, for example, one of the studies we've done is on contrastive explanation for reinforcement learning. I'm not going to go into too much detail about it. This is just a clip from one of my students' studies playing StarCraft 2, giving why StarCraft 2 agents are performing in a particular way here. But what I want to do is, again, do another quick quiz is, let's say that your agent is training Marines. If you don't understand StarCraft 2, I think you'll do all right in this because I don't know it very well either. Why are you training Marines rather than, so these agents on the screen here, rather than building more barracks? Now, we've got two explanations that I'm going to give you. It's more desirable to train Marine, to have more ally units, as the goal is to have more destroyed units and more destroyed buildings. That's your enemies, destroyed buildings. It's more desirable to action train Marine, the typo there, train Marines to enable the action attack, as the goal is to have more destroyed units and buildings. Would you prefer the explanation on the left? Put your hand up. 1. Would you prefer the explanation on the right? Put your hand up. Why would that be? What the difference is? There's a slight difference in between the two. And it's the existence of what we call an opportunity chain. So if we look at those two, the highlighted part I have here, the only difference that we described is why were we doing a particular action? And so what an opportunity chain is a concept from social psychology that says sometimes we do actions like this one. We do action A, not because it achieves what we're trying to do, but because it enables us to do action B, which helps us achieve what we want to do, or enables action B, enables action C, and identifying these. Now, interestingly, what happened was the one on the left came from a study that we ran, and we got people to do some things. And part of the study, we said, try and predict what you think the player is going to do next, what you think the controlling agent is going to do next. And they would predict it. And then we'd say, well, why did you predict that? And they would say, why? And so when we finished the study, what we had was some results from the model we've been running, but also a whole lot of data on how people explain the behavior of agents. And so we went back and I said, why don't we go back and look at that data and see if there's anything that people are using that we don't use, and see if that might be powerful. And we found this is what people were using. They were coming up with these causal chains. Well, I'm doing this because that allows me to do something else later, or it's doing that because it allows to do something else. And by simply, I'm not going to go into detail of how we came up with opportunity chains for reinforcement learning, but by doing that, we get this horrible looking graph here. What we see here, I'll explain the results. We had 3 different scenarios that we did: an adversarial scenario, a collaborative construction task, and a search and rescue task. We had this baseline one here, which was we're not going to explain what we're doing at all. We had this what we call causal explanation, which was the previous study we did, and we had the new study here, which we call a distal explanation. And basically the lesson that I think was interesting out of this was by going back and looking at our data and being a bit more human-centered than we had been previously, we're able to increase people's ability to make decisions in the environment, make decisions in a collaborative search and rescue scenario. And also we did a whole lot of stuff around what did you find more convincing, and just generally preferences, and did it build trust, help you to build trust. And we found, small increments in that information as well. And a second study, I'm only going to talk about these 2 studies. I think we've been doing stuff on concept-based counterfactual explanation in computer vision stuff. So this is from Raihan Zhang, who's one of my PhD students now. He's been doing stuff on conceptual base. So we saw saliency maps, and concept bases effectively, we try to learn what the important concepts that are learned in a convolutional neural network are, and what are the strong causes when they do predictions. And so here we've got the question, why is it a barn swallow rather than a cliff swallow? I don't know much about birds at all, but we give kind of, this is a very simplification of the explanations we gave our participants, but we give these counterfactual explanations. So we say, well, we think it's a barn swallow. These are 2 of the most important features. On the left, we have the image that was being explained, and on the right, we have the concepts that correspond to that. Should point here. This was we think this concept here is really important. And here's 5 other examples of that concept from the same training set. And we can see here, it's probably talking about the color or the texture of the underlying part of the bird. And also this was the second concept here. And again, it's talking about something around the neck of the bird, the color, or the concept. This was what we thought were strong predictors. And the reason we don't think it's a cliff swallow is because cliff swallows have this different color underneath the neck here. And if it had that color, so it's the same kind of thing as our arthropod example earlier. And so the concept extractor was stuff he did in previous work early in his PhD, and this work now is under review somewhere. And we did some human-centered experiments with people trying to detect model errors. So when the model is predicting the wrong class, how good are people at predicting errors? And we compared it to a couple of baselines. ACE is probably the de facto standard for concept-based explainers. ICE was the non-counterfactual version that Raihan did in his first paper in AAAI, and ICCE was the counterfactual one. And what we found was the sort of ones in white are the statistically significant ones. People judged that they were able to understand what was going on better when we did counterfactuals. They were able to make better decisions, which means they were able to figure out when the model was wrong and when their intuition was right. And they did it with a higher level of confidence. And more than that, we also did some stuff where we labeled, we looked at the concepts ourselves. Well, Raihan looked at the concepts himself, and he tried to extract, effectively symbolic concepts for what does this concept really mean, rather than just leaving it up to the person to interpret there. And we found without the label, people felt they understood a little bit better, but actually they were still making worse decisions in this case. So these are we're pretty happy with these results that we come out. They're under review right now, but it again showed just slightly human-centered, using conceptual explainers rather than saliency maps, using counterfactuals, people able to make better decisions. Okay, actually I'll skip this one because I realized we started a bit late. But it hasn't all been good. Okay, we've been doing some work. I've been doing quite a bit of work with Defence Science and Tech Group on sort of information, the use of information in making better decisions. So we did one, this is from a project trying to determine whether vessels off the Tasman Sea, in the Tasman Sea, were illegal fishing vessels. Although this isn't from the Tasman Sea, this is actually a picture from another project we've got with them actually. And we've been trying to sort of determine, is this something that we should send out the Coast Guard to have a look at? And even sometimes not real time, is it, a couple of days later, was this vessel in the region like this? And we've been doing plenty of other studies about things like evacuation from disaster scenarios. How do you evacuate people and get supplies? And just trying to make better decisions. We've had a little bit of success, but we've had a lot of things that look like this. Okay, so I'm not going to go into the use of what we were doing. This was an evacuation scenario, how you use certain resources to do things. And we had 3 conditions where we weren't explaining anything. We're giving a score, what's called a score-based explanation, and a score versus metric-based. Doesn't matter what they are. But what we saw here across 8 scenarios that we tested with pretty well-trained experts was, we kind of did a little bit better with our explanation here, and here, but not so much here. And in some cases, we did even worse. People did even worse. Almost everybody did worse in that last one by not getting any explanation at all. And this isn't just one study. I can show another graph that looks the same. And I can show you papers coming out now from people saying, we're not having any impact. We're giving people explanation, and they're not making better decisions at all. And part of it, I think, is that in the community, and where I'm guilty of this, we focused a little bit too much on understanding. Do people understand what models are doing, rather than can they then use that to actionably generate better decisions? I can show you projects where we have done a little bit better, but I can show you just as many where we're really not improving things very much at all. And I guess the question is, why is this the case? I can show you several studies, and this is to the point where people are claiming explainability is dead. In clinical decision-making, we should just forget about it and focus on accuracy and reliability. I'm not quite convinced yet that this is the case, though. So if we want truly explainable decision support, why are we not really getting these insights? So I think we've got to sit back and question the assumptions that we make in this field. So it started off, we imagine this: we have a decision maker, and they need to make better decisions. And for a while, what we assumed was, well, we use our explainable decision support on the left. That's supposed to be on our computer chip, I guess, on the left there. And we give them an answer. And now that we give them an answer, they'll be able to make better decisions. This leads to better decision-making. And what people found sort of 5 to 8 years ago was, actually, it didn't work. That doesn't work. That doesn't work at all. Why does that not work? There's no trust in these systems. People will start ignoring the answer most of the time if you've got medium to high stakes decisions. These work really well if you're doing advertising, where if you get 5% of people clicking on ads, it's good. But when you really need to get decisions right, people were ignoring this. And so we said, well, let's do something different, right? And then we said, well, same deal, same model here, but now we'll let people ask why. And if they can ask why, we can explain back. This will build trust in the systems. And therefore, if people trust these systems and they can provide insights, this leads to better decision support. Okay, this has worked a bit in some cases, but it's not working across the board, not working across many contexts. And even if we have really context-specific studies, it's not working really well. Why is that the case? We've done some fairly deep interviews with people and observed expert decision makers making decisions in these in simulated scenarios. And what we found was, while they're quite happy to ask why, they don't really engage very much with the information you provide back. So the model we sort of see is they make a decision first, then they ask a decision support system, what did you think? If it agrees with them, great, they move on. That's good, that's useful. Not very good though if they're wrong in the first place. So it's not really taking advantage of this fact. But if they make a decision and it disagreed, they kind of had a quick look, but they weren't really engaging very deeply. And in fact, some studies that came out of Harvard quite recently show similar results. They were doing studies where they were asking decision makers to make a decision. And they had a few different baselines. And what they said was in one of them, they took out the recommendation and just explained, this is the explanation for our decision, but we're not going to tell you what it was. And that forced people to engage more with the information, and they were able to make better decisions. They didn't over-rely on the machine as much as they normally would, and they made better decisions overall. This is what's called cognitive forcing people to engage with the information. But this model kind of works, but not really. And so we've looked at this recently in a paper. This is some work that is under review, maybe it's under draft still, with a couple of cognitive scientists, Robert Hoffman and Gary Klein from the US. And really what the lesson we have to learn is about self-explanation. So this is what we think explainability kind of looked like. This is what we've been modeling explainability on for a while. There's a machine, there's a person, you interact, the explainability happens there. But what we probably chiefly been ignoring is this part here, is that people are always involved in self-explanation. Irrelevant of what happens, the second they engage with something, they're trying to understand how it works and they're trying to explain this complex phenomenon to each other, to themselves, sorry. And when they're involved in this self-explainability, if they already think they understand it or they don't care, they're not going to engage in this middle part very heavily at all. And perhaps what's happened, perhaps the problem that we've been experiencing is more that we haven't engaged with the fact that people are actively got an abductive reasoning process going on in the background that they are using to make better decisions. We've just been interested in what's the information we're sending to them. And so the default option of this is the answer, I think, this is the reason why, make a better decision. Maybe that's not the model that's good at all, because they're weighing up a whole series of hypotheses. And so in this work, we talk about inductive, this is psychology and AI at the crossroads. This is under review that Robert and I wrote with William Clancy, who's another researcher in human factors. We talk about abductive reasoning and self-explanation. So abductive reasoning is a sort of 5-step process according to Pierce, who's a cognitive psychologist. We observe an event, and especially if that event is unusual, anomalous. We then want to know why that happened. We generate a range of hypotheses for why that is happened. We usually generate a handful of sort of 3 to 5 most likely hypotheses. We then try to judge the plausibility of all these. We look for information that supports some of these hypotheses, why some of them would hold. Good decision makers look for reasons why they don't hold as well, judge that plausibility. We then, using all that, we try to resolve to say this is what we think is the most likely explanation for some complex phenomenon. And then we might extend it later as more information comes in. We're going to refine that and we're going to go around that loop multiple times. Now, it occurred to us when we were talking about this is not really the way we've been focusing on decision support, explainable decision support very much. And maybe we should focus on this a bit more. What would that look like? What would sort of the requirements for these be? Well, let's think about observing an event. Probably the requirements are, well, we should be designing our interfaces to make it very clear what has happened. And more than that, maybe design interfaces to highlight unusual events, because those are going to be the most surprising ones here. And there is a bit of research in this in human factors, but not a lot, I don't think. Help to construct likely hypotheses. The default has been, this is my answer. I'm going to explain to you why. And if you disagree, too bad. Maybe we should be actually helping people to construct what are these likely hypotheses are. We've done studies with where we give 2 recommendations, but really it's about helping the person to construct hypotheses, not just telling them what ours are. Judge the plausibility of these. Well, help to explore how causes affect different outputs in a system and support things like contrastive analysis. That would be the way you would help them construct this plausibility of different hypotheses. Resolving the explanation, we haven't focused much around, okay, maybe we want to identify and record all this important information such that people can come back to it later when they want to extend what's going on. And then extending the explanation, well, support hypothesis revision and explore interactive explanation, because these things are going to change as more information comes in, especially in sort of complex domains such as disaster relief. Now, it seems to me that we've been focusing quite heavily on this in the AI community, help to explore how causes affect outputs and help support contrastive analysis. So there's been work going on in this already. And it's in fact, even in the first one as well, but we haven't really been too great at doing things like helping people generate different hypotheses. And that's kind of that study I talked about where they withheld the hypotheses, the people had to generate them themselves and then look for information. So it seems that maybe a better way to approach things instead of answer explanation would be to say, for example, well, this is a complex situation. Why don't you tell me what you think? Or the machine would ask, why don't you tell me what you think are the two most likely things that could be causing this? And then I'll give you information for why I think that's might be a good idea. And I'll give you some for why I think that might not be the right idea here. This corresponds a lot more with the naturalistic decision-making community's observation about how people make decisions. There's a whole lot of possible hypotheses. They shrink it down to 3 or 4 very quickly. They look for supporting and conflicting information for those. But it's not really the way we've been supporting it. So it gets back to the title of the talk, is explainable AI then dead? Well, I mean, I don't think so, right? Because we have been working on some of these topics, and I don't think some of the tools that we've come up with are far away from what this is. I think the way that we use them and the way we embed them in contexts has to be explored a lot more. And there's some other really low-hanging fruit things that we can help out, such as constructing hypotheses. So I think the studies that are showing we're not going very far in this, we're probably not taking this decision-making model very well. And so what we're really keen to do, I mean, Robert, my co-author, he's about to retire. What I'm really keen to do is look at, okay, maybe we should focus less on this interaction between two people and focus more on the decision maker and how they make better decisions and how we can support them. I think we haven't quite done a good enough job in that there. So the key takeaways from this talk, the lessons are, I think XAI is not just a technical problem. As a field, I think we've figured this out in the last 5 years and we're getting a lot better at it. And the insights from the social sciences, the explainability, explanations are contrastive, social, and selected. I had some other insights in the paper that I didn't give in the talk. And validation on human data at some point is important. And I want to point out here, I'm not saying every single paper has to have human validation data, but we have to do these studies to convince ourselves, proper scientific studies. This is helping understanding, this is helping decisions. But maybe people don't engage with XAI, we can't assume that they're going to all the time. And our experience suggests probably they're not when we do this kind of stuff. And we should be focusing maybe a little bit more on the adaptive reasoning self-explanation process and helping to support that for these medium and high stakes decisions. And for this, we need to improve cross-disciplinary links. We need to engage deeply with experts of their field in that context. We need to engage with people who understand decision-making better than the technical people. We need to engage with people who are good at designing these interactions for machines. And obviously the people who are writing the technology need to know to say what's feasible. Explainable AI as it is may be dead, but we've got this idea of long live explainable AI. So this comes from the idea of the king is dead, long live the king. The old king is dead, there's a new king. So perhaps the way we've been doing it, for some context, we should put it to bed and move on to this new idea. Thanks very much. And thanks to my collaborators on this work too. And I suppose there's a Q&A now, is there, for a couple of minutes? Oh, yeah.
For Q&A. Thank you so much, Tim. That was a very scholarly take on a very tough, tough topic. Okay, questions? So, go.
Yeah, that's a great question, right? Thank you for your support. The question was, people prefer some explanations, but is that useful? That's a bias, and is that a useful bias? And absolutely, that's the point, right? And that's the point about doing more studies. We have done studies where we ask people, what do you prefer? And shown that they prefer things that don't help them. And I think the point of that example is not that we should then give the one that they prefer, but when you are giving them, you have to be aware of the fact that they have certain biases they're going to they're going to prefer, and therefore they might not accept what you're saying. So you have to understand that these things exist. And yeah, we found in some studies, people rate, I prefer this, and I'm far more confident in my decision, but their decisions are worse on average over fairly large sample sizes. So it's a very good question.
Very, very insightful talk. I want to come back to your mention of whether it's been successful or not in terms of is there. I'm wondering if that is the right measure. For example, you might use, explainability to scrutinize a model to see whether it's fair or not, regardless of whether someone outcome, or to give people the agency to understand why they're making a decision, regardless of whether they make the right decision. I'm wondering what might be the replacement measure if changing in how the outcome is.
That's a great question too. So I agree with you entirely. So the stuff at the end was all about decision support, right? Explainable decision support, I think. And there's a whole range of contexts where you probably don't care about improving decision making a great deal. I would say that I don't even think decision making is the final task. So if we're talking about clinical decision making, it's also a pretty strong assumption to say if we can improve decision making, that will improve patient outcomes. There's actually quite a bit of work to show earlier diagnosis doesn't necessarily lead to better patient outcomes, right? So, what is it, sort of bowel cancer testing kits that have been rolled out across Australia hasn't improved patient outcomes. What it's improved is survival of some patients at the expense of them being those who have still died early being sick for 5 years, being treated for 5 years instead of 6 months, right? So I think that's a pretty big assumption to say decision making. So the measure for there is improved patient outcomes, but of course that's a multi-year. That's a 10-year study that we can't do. We need to understand whether we make better decisions first. And then there's contexts where I agree with the decision making doesn't matter. You're not making decisions whether to, I guess, serve an ad to somebody. That's done automatically. But you do understand why people would buy into an ad and why it's doing those types of ads. And there's a whole range. That was only around decision support, that context in my view. And I don't know what other mechanisms are. But the bias and fairness is an interesting one, because a lot of that research assumes that we have, measuring bias, fairness, we have predefined labels for everybody, their gender, their ethnicity, which is not reality. So how do we help people untangle whether we've got an unfair classifier when we don't have that information is really interesting. Yeah.
Hey, Tim, thanks for the talk. You reminded me of a bunch of things around applying research into human error into, say, critical systems design, and where understanding how we're vulnerable to make certain errors is part of what's important to reflect on. And I wonder if you've looked at any studies of this is why you might be making a bad decision here. So this is a kind of, you've made this choice, but here are the reasons why there might be a bias here, coming back to Larissa's point.
Yeah, I have. So, Gary Klein? So Gary Klein is he's the person I read the most now. He started a field called naturalistic decision making, and so naturalistic decision making is a subfield of cognitive science that says there's a lot of cognitive science research, and it tells us a lot about how 18 to 22-year-old undergrads in North America think about synthetic tasks in a lab. And that's a harsh point. What they do is go out and do cognitive task analysis and study how experts make decisions. And I've read quite a bit of his research in at the start of this year, and because he's got a really interesting view on how people make bad decisions. It doesn't not align with the lab studies. And there is some really interesting things around. He has some interesting things to say about that. I probably won't go on about it too much, but a lot of studies are around, well, here's why people make errors. And some of his more recent work says, well, that's really good, but a lot of those things you can't do a priori, right? You spent too much time looking at an option that was infeasible. You don't know that a priori, so that's hopeless, right? And he pins down, I think it was 2 things that he thought were really critical. I don't remember now, but really critical. So I've been reading that kind of naturalistic decision-making work that's around expert decision-making in sort of, I don't know, ecologically valid tasks. So what, should I just click on the chat? Yeah, and Ahmed's right. I mean, huge human judgment still beats a lot of medical. Is it just teaching people to critical? Oh, that's a good question. That's way too philosophical for me to answer, I have to say. That's a great question. And in some of it's about forcing people to think critically. And that's what Gary's line is about, how to teach people to think more critically in a feasible way. Oh, and this one's supposed to look at this one too. Oh, it's the same thing. Sorry, yeah.
way to move forward is to not simply think about decision making as decision making, but to think about the social process. I really like your idea of drawing from philosophy, drawing from social sciences, because I think there's multiple layers of it, the tacit nature of knowledge. So it's sort of a knowledge creation, knowledge transfer, integration process that you would like it to be as humanly as possible. So I think, and that's not necessarily something you can easily map, as you have mentioned, it's very complex. And the selections of reasoning has a lot of underpinning sort of cognitive, but also socializing process. And I think to draw from actor network theory, for instance, if we think about these AIs becoming agents, having agencies, and coming to the network of human actors and becoming almost like actors, I think it's a process to study from a social theory perspective to see. Perhaps the problem now is that they are very much mechanistic. They're very much a machine. They're not really humanly. They can't be incorporated in this meaning-making, sense-making process, because we all know from social theory, it is very socially constructed, the meanings. And in terms of clinical decision-making, for instance, the clinical judgment is not simply an explanatory seeking process. It's weighing all these considerations, the patient situation, the sort of cost benefit, the economic, and all these things, the expertise level. And we know from studies, sort of the use of clinical decision tools depends on the levels of the clinicians who are making the decisions. So I think it's a sort of a compounded social process that needs to draw from a lot of more philosophical underpinnings. I don't necessarily have any recommendation, but it just triggers a lot of thoughts.
Yeah, it's a really good observation. We did some early work that looked at that from a trusted autonomy perspective, nowhere near as deep as what you're talking about. I worked with Yoshi Kashima, who's a social psychologist, on how people come to common ground on decisions and what the grounding process is. That funding from that project finished and we moved on. But this is also another observation that other people are having. And we've got not the paper I talked about, another paper with Robert Hoffman and Gary Klein, where they made the point, not me, in the draft, about the ecological validity of a person with a machine. But actually the fact is, when you make clinical decisions, a radiologist from oncology goes into a meeting with 8 other specialists who are all they're all trying to make a collective decision, and the surgeon wants to slice somebody up and the oncologist wants to send them for treatment. And there's this whole process where this little tool that you've got is just part of the input, and it becomes way more complex than what we're talking about. And I don't know, I think like you, I don't have any recommendations on where to start in that research. It seems very complicated and hard to study and requires pretty deep study of how people make decisions collectively. And that there are people at Melbourne Uni who do this, but not me. Yeah. Not that I wouldn't like to.
Okay, thank you very much, everybody, for some great questions. Please join me again in thanking Tim for an excellent talk.